Problem 6.6.19. I believe we did this in class. Could be wrong. In a survey of 1,109 people, 828 said that they voted in the recent presidential election. Voting records show that 66% of eligible voters actually did vote. So that's B, 0.66. And then they repeat it. That's our assumption. Given that that's true, find the probability that among those 1199, at least 828 actually did vote. At least means 828 or more. So with a continuity correction, it'll kick back to 827.5. But we also need mu and sigma. So we use a calculator to find mu and sigma. Remember, mu is NP, so it's 1199. P is assumed to be 66%. Oops, too many nines in there. There you go. Oh, I see what I did wrong. I'll just do second enter. I need a multiplication sign in there. There we go. So 791, that'll be our N, 791. And then the square root of NPQ is sigma. So we'll just take the square root. I'll do second answer, which is 791.34, times Q, which is 0.34. If 66% voted, 34% didn't. So sigma is 16.403. We'll do 3 decimal places. Should be sufficient. So remember, we wanted the probability on the normal that x is greater than or equal to 828. So we got to drop back a half unit. To include 828, we have to go half a unit back between 827 and 828 on the normal. It's continuity correction. So open up StatCrunch. Calculator normal. First set the mean. The mean was 791. That's mu. Standard deviation was 16.403. That's our sigma. We want the probability that x is greater than or equal to 827.5. 827.5. Compute. 0.0130. (1.3%). Small number. What do the results suggest? Well, some people are being less than honest because P of x is less than 5%. The probability is calculated. See, if 828 said they voted, and voting record shows 66%, which was 791, that's a discrepancy of 9. That's the discrepancy of 37, which is over 2 standard deviations. So it's a 5% is our typical cutoff. Well, that's it. Okay, so that was 6.6.19. Just to do a catch-up to show you how good that normal approximation is, let's go ahead and do the actual binomial, since we got the power to do it. Only now we have to put in the actual n, which was 1499, was it? I better open the calculator to see. 1199. So 1199. And P was 0.66. And we want the On the binomial directly, we want the probability x is greater than 828. We don't need to correct this because it's a discrete. And there you see 0.0133. Pretty close. Remember the actual, or the approximation was 0.0130. The actual was 0.0133. Pretty close. All right. So that is it for problem 6.6.19, I believe. Dr. K, out.